Hello everyone, this is Kalpana working as an assistant professor in AIDS department of SNS College of Engineering. Today we are going to discuss about contiguous memory management. Before that we have discussed the techniques that we have used in memory management, and we are going to elaborate, I'm going to elaborate contiguous memory management now. Let's get into the topic. So actually contiguous memory management scheme is divided into two types. One is fixed size partition scheme and another one is variable size partition scheme. So here in fixed size partition, so we are going to divide the main memory into some continuous blocks. So each of fixed size, let's say 100 MB or 200 MB, for example I'm telling. So 100 MB or 200 MB. So for each block is of the same size. If you take 100 MB, so all the blocks, n number of blocks you will be having. So it is all of having same size, let's say 100 MB. Okay, so because irrespective of the size of the process, each is allocated a block of same size memory space. So this technique is also called as what? Static partitioning. So we are not considering the process size here. So default we are setting a block size of any size, let's say 200 or 300 MB. So we call this scheme as static partitioning. So here the number of processes that can stay in the memory is called at once is called the degree of multiprogramming. So here it is based on the blocks available in the main memory. This degree of multiprogramming depends. So hence the degree of multiprogramming of the system is decided by the number of blocks that is being created in the main memory. So based on the blocks you have in the main memory only, we can decide the degree of multiprogramming here. So this is just an example of fixed size partition scheme. So first we know in main memory operating system is being loaded. It is being loaded here, and next is your user process. So these are all your user process. Okay, it is a fixed size memory. So here they have set 5 MB. So for each block it takes only 5 MB of process. It can hold only 5 MB of process. So let's say your process 1 is size 3 MB. Once we are going to load this process into this main memory, so this block is being allocated here. Okay, the first block of 5 MB is being allocated to which process? Process 1, it is of 3 MB. And next, let's say process 2 is of size 1 MB, that is allocated to the very next block. Okay, so like this only the contiguous memory will work. So one after the another without any break, we are going to allocate the processes next. So contiguously, continuously. So in for example, the second process, it is of 1 MB, but we are allocating to 5 MB of size. And process 3, it is of 4 MB, we are allocating 5 MB. Okay, so like this in fixed size partition, we will be allocating the process. We are based on the, not based on the size of the process. We are not worrying about the size of the process, how much it is. We have fixed some kind of size to each block. So based on that size only, we are going to load that process into the memory. So this is your fixed size partition. So we have seen the diagrammatic representation, how the process is being allocated to the fixed size blocks. As I have told you, process 1, it is of 3 MB of size, but we have allocated 5 MB of size block. And the process 2, it requires only 1 MB of data. But what happens? We have allocated 5 MB of data. So the remaining space will be 4 MB. For the process 1, it is of 2 MB. So likewise for process 3, it is of 1 MB. So free memories, okay, we say free spaces are available for each and every block, right? So this we call it as internal fragmentation. So internal fragmentation, which means inside the block, some free amount of memory will be available. So that is of no use. It is actually a memory wastage. So that we call it as internal fragmentation. So we'll see what is external fragmentation and what is variable fragmentation, and in variable fragmentation how what are all the disadvantages we are going to face. Everything we'll see in the next lecture.